Okay, here's the second video in 1.4. So we're going to look at another system here. So if you remember, our steps are to create a new system with just two variables and two equations by eliminating one of the variables in this equation. So let's go ahead and look at first what we can do. So you see here we've got, if we look at our x's, we've got x, 5x, 4x. We've got y, 5y, and y. Then we've got z, 5z, and negative 3z. So what we're going to do first is rewrite this as a linear system in two variables. So if we take our first equation and multiply it by negative 5, that's going to allow us to get our z variable eliminated. So we've got x, 5x, y, 5y, and z, 5z. Now you don't always have to eliminate, z. You can try to eliminate any of you want. But if you see right here, right now, all of our variables right here would cancel out. So when we go ahead and do that, and we add these together, we get this false statement like 0 equals negative 7. Again, what we've done is we've multiplied our entire first equation by negative 5. And by doing that, we eliminate all three of our variables. Now again, you're not always going to see equations like this, but this is to show you an example of when we're going to have a false statement. So what you're looking for when you're looking at your equations are variables that you can easily cancel out. So here we see that just multiplying our first equation by negative 5 is going to all of a sudden cancel multiple variables out for us. So when you see that, you want to take advantage of it and see what's going to happen. You may have one of these special cases. So because we get this false statement, 0 equals negative 7, let's look back and see what happens. When we obtain a false statement, such as 0 equals 1 or 0 equals 7, the system has no solution. So what that means is this system has no solution. So when that happens, you just type that out, no solution. There's nothing else to be done right here. You've gotten as far as you're going to get, and there's no solution. So keep that in mind. Also, remember, if you obtain an identity, that there's infinitely many solutions. So right now, I want you to go ahead in the text box that pops up, just do the first problem right here. Do the first problem and write it in the text box that pops up now. Okay, now that you've done that one, I want to show you one more example. So here's another system that we have right here. We've got three equations and three variables, and we want to go ahead and go through our steps to solve this. So let's go ahead and look at our system right here and try to see what we can do. So the first step is to rewrite this with a linear system in just two variables. So you want to go ahead and analyze your equations, see what might be easy to cancel out. In this case, we're just going to add equations 1 and 2. Because we see if we do that, we've got z and negative z, that's going to cancel out. Anytime you see that it's going to be really easy to cancel out one of your variables, take advantage of that so you don't have to do much work. So when we add equation 1 to equation 2, here's our new two variable equation that we get. Now, we see right here, we can also add equation 2 to equation 3. So our z's are also going to cancel out here. And we've got another two variable system. So here we've got 2x minus 6y equals negative 6, and we've got 2x minus 6y equals negative 18. Well, you see right here, 2 and 6, negative 2 and negative 6, we can multiply this first equation by 3 to turn both of these coefficients into 6. And because these signs are the same, we have to multiply our first equation by negative 3. So let's go ahead and do that. We want to multiply our first equation by -3 and then add it to this one. So here's our first equation multiplied by -3. We get -6x plus 6y equals 18. And when we add it to our second equation, you'll see that everything cancels out. And we get what's called an identity statement. 0 equals 0. It doesn't always have to be zeros. It could be 10 equals 10, 20 equals 20. Anytime you get an identity statement, if we look back here, when we obtain an identity, the system has infinitely many solutions. So what this means right here is that our system has infinitely many solutions. Whatever we plug in is going to work. So again, just like the previous example, you stop right here. There's no further solving. This right here, our system has infinitely many solutions. So what I want you guys to do now is I want you to go ahead and solve number 2 in the text box that pops up. Just number 2. Go ahead and solve it right now.